Hi everyone and welcome to another Physics 210 lab simulation walkthrough. My name is Alec as always, and today we're going to be talking about collisions, conservation of momentum, and all of that. As I will probably continue to say at the beginning of all of these videos, please go ahead and make sure that you've read through the theory section of the data of the lab manual that I posted along with this. And when you're ready to jump in, go ahead and navigate to this website right here to get a start on this lab. So, basically what we're going to be doing is throwing these balls at each other, having them collide, and seeing what happens when they do. By way of doing that, we'll measure, kinetic energies and velocities and momentums and things like that, and I'll have you all do some calculations associated with that. So let's go ahead and get set up here. First, it says to check the velocity vector box in the top right, which, as you can see, I've done here. Click on the More Data button. So, originally it looks like this. Go ahead and click on the More Data button just so you can record some data while we're going. And it says to set the elasticity to 100%, which I have done over here. Now it says to set the initial position of the first ball to 0 meters, which is done here. Set the initial position of the second ball to 1 meter here. Set the initial velocity of the first ball to 1 meter per second, and the other one at 20 meters per second. So there you are. Now, the first, obviously, part that we're going to be doing is elastic collisions, as noted up here. So basically, in an elastic collision, what happens is two objects collide and they bounce off each other, right? So they don't stick together at all. They just kind of bounce off, and maybe go in opposite directions, or maybe, one kind of like, if you're playing pool and you hit, you hit the cue ball, and the cue ball collides into the other one. It kind of glides along the same direction, but they're no longer touching, as what's going to happen here, right? So you can see this ball's still moving. This one is moving forward as well. If, let's say, this ball was a lot less massive than the second one, it might, turn around and go in the opposite direction, as you can see here. But in any case, just to give you an idea of what could happen. So we're going to set this one to 2 kilograms and go ahead and start. And the other one should be 1 kilogram. Now it says, I'm going to leave step 3 for you all to do at home. Basically, given this configuration, calculate the initial momentum and kinetic energy of the first and second ball, and then also calculate what you think after the collision the final momentum and kinetic energy of the first and second ball will be. We're going to use this to calculate some percent errors and whatnot later on. So go ahead and do that. And once you've done so, we'll go ahead and move on with these measurements. All right, so it says to press play and watch the simulation go to get an idea of what's going to play out, and I kind of already did that, so I'm going to skip that one for now. Now it says to press restart, which of course I have done, and to press play, and then pretty much immediately, and then press pause before the first ball hits the second ball. So I'll show you what I mean here. So okay, right now you can see that the first ball is about to hit the second ball, but hasn't, which is exactly what we want. And we're going to click this button that says show values on everything, and it'll basically show you all the information you need here. So go ahead and mark down that before the collision, the momentum of the first ball, which is the 2 kilogram ball, is 2.0 kilogram meters per second. And again, that's because the velocity is 1 meter per second and its mass is 2 kilograms. And it, of course, marks its velocity up here for you. And, of course, since the second ball is not moving, its velocity is 0 and its momentum is 0. So now we're going to uncheck that and allow the simulation to go forward a little bit further, until after the balls have kind of hit each other and they are, progressing through the screen. So okay, there we go. Now everything should be in a steady state, and if I kind of, if I rewind just a little bit, you'll notice that they're kind of moving both with a constant velocity here, and we are told to check the show values button and record the velocities and momenta again. So now you'll see what happened is that the first ball slowed down a little bit. It is now going with a velocity of 0.33 meters per second, and its momentum thereby is reduced to 0.67. So go ahead and mark that down for after the collision for the first kind of scene here. And what you'll notice is that the first ball imparted some of its velocity on the second ball, which of course it did because they collided. So again, it's like shooting pool. This is going to happen, right? So because the velocity of the first ball is 1.33 and the mass is 1 kilogram, of course the momentum in this case is going to be the same as its velocity. And I chose these values to make the math somewhat easy for you guys. So okay, anyway, that's the first collision. I'm just going to let it kind of play out for another second just so you can kind of get an idea what's going on. And now it says to repeat steps 3 through 10 with the first ball 1 kilogram and the second ball 2 kilograms. So I'm going to go ahead and restart it, and then make this one 1 kilogram and make this one 2 kilograms. We're leaving everything else the same, and we're going to go ahead and see what happens. So again, go ahead and make all those calculations once more, and once you've done that, come back and check out this data collection section. So with the configuration, press play, and then I'll pause it right before it hits the ball. Now you can see that, because we've given this ball a mass of 1 kilogram and an initial velocity of 1 meter per second, its initial velocity and momentum are both going to be 1, but of course, do note the units are different there. Now I'm going to let them hit. All right, so now the velocity of the first ball is negative 0.33, and its momentum is negative 0.33. And you'll notice it imparted some of its original velocity and momentum on the second ball. So the second ball now has a velocity of 0.67, and its momentum is 1.33. So go ahead and mark those down, and we can move on to the next section of the lab here. So this time, or for this next section, we're going to be running inelastic collisions. So I'm going to take the elasticity and bring it all the way down to 0. And basically the procedure is going to be exactly the same as before, except with the elasticity at 0. Knowing that it's an elastic collision, let me set this back up here. We're going to set the first ball to 2, not 25, 2, and the second ball to 1. And of course we want the positions to be 0 and 1 respectively. And I'm going to uncheck this show value section here. Go ahead and calculate the initial momentum and kinetic energy of the first ball and also calculate the final state stuff, knowing here that the collision is going to be completely inelastic. And I'll go ahead and play it out to show you what I mean by that. So what you'll notice here is that the ball is actually stuck together. Essentially, that's what it means by inelastic. The two things will stick together and kind of move as we go. Just to give you an idea of what it would look like, we're not actually going to be taking any data like this. If it was like, let's say, half elastic, then this is kind of what would happen here. So they would stick together, and then basically momentum necessarily would be distributed between the two of them. All right, but back to the actual experiment. I'm going to hit play, and then I'm going to pause it right before they hit each other. All right. Now I'm going to hit show values here. So you can see this is pretty much the same as it was the first time around, where the velocity of the first ball is 1 and its momentum is 2, and but you'll see what happens after they hit. Okay, so it's a little hard to read, obviously, but now they have the same velocity, and their respective momenta are different, right? So the velocity for both of them is 0.67 meters per second, but the momentum of the first ball is 1.33, and the momentum of the second ball is 0.67. However, when you're doing your calculations, you're going to need to treat this as a system now. Now, keep in mind that the momentum of the entire system is going to be the same, right? So you have to add these two masses and then calculate the total momentum of these objects as a combined total in order to make these calculations up here, okay? So do keep that in mind as you go. And I'm going to let it progress just a little more. All right, so, the values stay consistent because, we're not dealing with any kind of friction or anything like that here. We're just dealing with a pretty ideal simulation, which is nice for, checking values and whatnot. So I'm going to go ahead and reset it. And we're going to set this mass to 1 and this mass to 2. And we'll see what happens this time. Pause it right before it hits. Of course, its velocity is 1 and its momentum is 1, just like it was before. And after they collide, now the velocity for this ball is 0.33, and as it is for the second ball as well. And the momenta are slightly different in that this one is 0.33 and this one is 0.67. Now remember, as you're making your calculations, you need to add up both of the masses to get the total momentum, and then do your data analysis and stuff with those. So again, as always, feel free to rewatch this video as many times as you need. Really, what we're looking for is the data from those 4 collisions. So the first one with the 2 kilogram ball on the left at 100% elasticity, the second one at 100% elasticity with the 1 kilogram ball on the left, and then the third one with elasticity at 0 with the 2 kilogram ball on the left, and the fourth one with the 1 kilogram ball on the left. So go ahead and either take all that data yourself, or you can use the data from this video and then go ahead and work through the data analysis and question sections. Of course, if you have any questions for me, you can always email me or drop by my question session from 1 to 2 p.m. every weekday. And thanks for watching. Have a good one.